Hello everyone. We are going to talk about the mean and the standard deviation of the sample mean. First, consider a variable as x. In statistic, we are going to use capital letters to denote a variable. Suppose this x has a normal distribution with mean mu and standard deviation sigma. X has a normal distribution with mean mu and standard deviation sigma. In this section, we are interested in the distribution of the variable x bar, that is, the sample mean of the variable x. When the variable is x, its sample mean is x bar. That is just a notation. For variable we will use x. For the sample mean we will use x bar. In principle, this x bar also has a normal distribution with a different mean. Here mean of x bar, that's why it is mu x bar, and a different standard deviation, which is standard deviation of x bar, that is why it is sigma x bar. Now we are interested in finding these mu x bar and sigma x bar in this section. Again, mean of the sample mean, that means mean of the variable x bar, is given by mu. Let's revise what is mu. Mu is the mean of the variable x. Here this is mean of the variable x bar. Here we can see these two are the same. So even we are going to consider the sample mean, which is x bar, or the variable x, we will get the same mean. Now let's see about the standard deviation. So in other words, the standard deviation of the sample mean is standard deviation of the variable x bar. It is given by this formula. Here sigma divided by square root of n. Sigma is the standard deviation of the variable x and n is the sample size. That means the number of observations in the sample. So by using this formula, we can find the mean of the sample mean, and by using this formula, we can find the standard deviation of the variable x bar. Now let's use these two formulas to calculate the mean and the standard deviation for a given problem. The mean living space for single family detached homes is 1742 square feet. Assume a standard deviation of 568 square feet. Now let's try to find and identify these terms in our usual notation. Here the variable is the living space. So let's take this x to be the living space and mu is the mean of that variable. So mu is equal to 1742 and sigma is the standard deviation of this variable, which is 568. Part A, for sample of 25 single family detached homes, determine the mean and the standard deviation of the variable x bar. So we are asked to find the mean and the standard deviation of the variable x bar when the sample size is 25. In part B, we are asked to repeat the part A for a sample of size 500. So what is the difference between these two parts is, here the sample size is 25, here the sample size is 500. So let's calculate the mean and standard deviation for both these parts, and we will compare those two at the end. First, I have written the things in the problem: mean, standard deviation, and sample size. First, we will calculate the mean, which is 1742. Here we got it because mu x bar is equal to mu. And the standard deviation of the variable x bar is given by this formula. Sigma is 568 and n is 25. So make sure to put the bracket, the square root. Then you will get the answer as 113.6. Here we can see this mean doesn't vary with the sample size, but here the standard deviation varies with the sample size. Let's see these things very clearly from part B. Again, we are going to list the values for the variables, and here the difference is we have a different sample size, which is 500. Then the mean of the variable is mu. Again, it is 1742, and it is convinced that the mean of the sample mean doesn't vary with the sample size. But we know the standard deviation varies. Here we are going to put 500 for the standard deviation. When we are going to calculate the standard deviation, then we will get the answer as 25.4. So if we compare these results with the previous part, which is part A, we can see in part A it was 113 something, and here it is 25.4. So obviously it has decreased. So we will end up with two results after this example. The first thing is the mean of the variable x bar is same as the mean of the variable x. In other words, the mean of x bar equal to the population mean. Then for larger sample sizes, we will get a lower standard deviation for x bar. So those are the two results we got by looking at this example. So in this example, we have covered the things on finding the distribution of the variable x bar, which is the sample mean. So here we consider to find the distribution of the sample mean, and specifically what is the value of the mean of it and what is the value of the standard deviation of it. Hope you enjoyed this lesson. Thank you very much. Have a good day.